reading the contents of these various honeycombs here, particularly at the back. I think you have a better view of what's in there. But it does tell you that since the first International Polar Year, scientists and science as an enterprise has been getting much, much busier. By comparison, Bajprek, for instance, he was fully funded by the Austrian-Hungarian Navy for the first International Polar Year, and he took his time coming back and spent several years working on just one publication that's still a classic, the first textbook on sea ice. In the 1950s, from what I can tell, I suspect that a lot of these scientists were also fully funded just from one funding institution, whether it was the National Science Foundation or Precursors, Office of Naval Research, what have you. And there was time, as Neil has shown, to really think about the data and actually have graduate students who are still with us now take their time and put a lot of thought and effort into developing and furthering our understanding of the way the world works. And nowadays, you look at the typical IPY researcher, typically people have between 4 and half a dozen projects that provide for their salary with on average 2 to 3 years duration. You're expected to publish several papers a year if you want to be successful. And the question, of course, can you raise whether that results in a disproportional increase in the amount and the depth of knowledge you have. One thing that's for sure, though, is certainly makes the parties all less interesting. And again, that's sort of an interesting contrast here. But I just want to spend a few more minutes now talk about what, in fact, is in store for the International Polar Year. I would encourage you to visit this website here to find out more what UAF or the University of Alaska is doing. If you look at the statistics here, you've probably read this by now. The University of Alaska, just as during the IGY, is very prominently represented in this research. And in many ways, I'll just show you a few examples here of projects happening at the University of Alaska. In many ways, we're doing studies here ranging from studies of Bering Strait, looking at caribou and reindeer across the Arctic, sort of living conditions in the Arctic that's done by a colleague at the University of Alaska in Anchorage. We have the University of the Arctic's Education Coordination Office here that's headed by Lena Sparrow with the School of Natural Resources Management. There's a census going on here, a census of marine life, where they're actually trying to count all the seals and try to figure out how many species of phytoplankton there are in the Arctic Ocean. So there's a whole range of activities going on. I just want to highlight one thing, though, and that is that if we look at the sort of the present state of the world, and you compare that to the 1950s, where again, Carl already mentioned this, the 1950s was very much governed by the early stages of the Cold War, and it's remarkable to see that a lot of the collaboration during the IGY took place in spite of that, in part because scientists tend to have much better connections amongst each other, regardless of their national origin. But of course, the 1950s was also, of course, as you probably recognize, I'm not talking from experience now, but the 1950s was a period that was in many ways much more defined by the early stages of the Cold War. Now, arguably, the defining aspects of this present International Polar Year is that we have a series of 4 massive changes underway, in particular in the Arctic, and that's the example I'm going to be taking today here. And that is that we're seeing arguably unprecedented change in the climate. We're seeing substantial geopolitical change, similar to the discussions coming out of the IGY with regards to how do different countries want to look at Antarctica and its the territorial claims, which was resolved in a very, very forward-looking fashion to basically suspend a lot of these territorial disputes and just look at Antarctica as a continent for science and preserving this legacy for mankind. Now, in the Arctic, in part as a result of this perceived opening of the Arctic due to climate change, retreat of the sea ice cover, a lot of these territorial examinations of territorial claims are coming back up again, and that's something that's driving a lot of the discussion. And then, of course, we have substantial economic activities in the north, which, of course, here in Alaska, for instance, is a focus on oil and gas resources, both on land and now in the offshore. And the fact that all of these changes are somehow interconnected, and you can draw as many arrows in here as you'd like, really make the sort of the ground or the landscape during the International Polar Year now is probably as complex as you could ever wish for as a scientist, but that is both a challenge and an opportunity. And so I just want to spend a few minutes telling you how some of these projects that are part of the International Polar Year now fit into this very, very complex but also very interesting and challenging picture. Now, the U.S. contribution to the International Polar Year is going to come from a number of agencies. The National Science Foundation has taken the lead, and these agencies have committed to basically investing most of those funds into the establishment of an Arctic observing system, or an Arctic observing network. This is built on a broad initiative, the study of environmental Arctic change, that's been underway for almost 8-9 years now, and that seeks to put into place a network that isn't just, if you compare, again, looking back to the 1950s, you have these different divisions. I shouldn't be saying divisions because that's doing, not doing justice to what was happening back then, but it was typical for research groups to focus on their specific discipline. What's different now is that in particular in the Arctic, we're recognizing that changes in the oceans, changes in the atmosphere, changes in the ice cover are impacting ecosystems, but there's also ecosystem change. If you look at release of gases from the tundra in Siberia or Alaska that is driving climate and is feeding back on what's happening in the atmosphere and in the oceans, these things are interconnected. And then in particular, if we're interested in how all of these things are going to impact human activity, we need to understand this as a system. And so putting in place an observing network that recognizes that there's interconnection between these different types of changes, different processes, is a very, very important and also very, very difficult aspect of the challenge that we have for this present International Polar Year. Just one very quick example. There's again, I think this university has been very, very successful in getting funds and support for this. This is a list of projects that are now officially recognized as being supported as part of this observing network initiative, but I'm very positive that there's going to be many, many more to come. I think that possibly the University of Alaska will be the one institution in the country that will have the largest number of funded Arctic observing network studies. And so the one that I want to briefly talk about is relevant for people here in the interior. This is work by Vladimir Romanovsky, who is proposing to put in place and link different permafrost observing sites around the Arctic. Both him and Tom Osterkamp, who's built up these capabilities, have been very active along the Hall Road. Their work has shown that permafrost temperatures in Fairbanks starting in the 1930s. So this is the second International Polar Year here. Permafrost temperatures at different depth levels, this is now just the uppermost 3 feet of the permafrost, have been warming, in particular starting off from low temperatures in the late 50s and early 60s. And what's interesting here is that once you talk about environmental observation, of course you have to keep in mind that there's longer term variations or even oscillations. For instance, the